Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Battle Blind 75 coding series. So today's problem is on TaskScheduler. Let's quickly jump into the problem statement, understand it, and start solving. Okay, I already have it open because last time we have solved the minimum height tree. You can find it in the list. We start with TaskScheduler. So sorry, I'm a little late for today's video. Actually, I already solved this problem, but the explanation was still quite confusing. So I thought, okay, maybe I need to record this again. I did upload it and then I had to remove the video, and now I'm going to upload this again right after recording this. Okay, it's already quite late, so bear with me. Okay. Given a character array, tasks represent the task a CPU needs to do, where each task represents a different task. Tasks would be done in any order. Each task is done in 1 unit of time. For each unit of time, the CPU could complete either one task or just be idle. Okay. However, there is a non-negative integer n that represents the cooldown period between two same tasks, the same letter in the array. That is, there must be at least n units of time between any two same tasks. Okay. Return the least number of units of time that the CPU will take to finish all the given tasks. Okay, so we are given the task list like this. We have A, B, 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 and the idle time slot before repeating the same task, that is after A repeating A again, we have to wait for 2 slots. So the output is 8. We worked on A, we started with A, we picked up B, then we waited for idle period, then A, B, idle, A, B. Now we could have gone with A, wait for 2 time slots, idle, then B, then A, idle, B, and this way we would have consumed more time. The best approach was to, since we have to wait for 2 time slots before picking up the same task again, why not complete some other task in that meantime? Now the other task was B, but again B also have this issue that B cannot be done again a B tasks. We have to wait for 2 idle slots. So we wait for 1 idle slot. In the next one we pick up A. So we have a 2 slots gap between 2 A's and 2 slots gap between 2 B's. Similarly, if you see A, B, 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 n is equal to 0. So we don't have to wait for any time slot before picking up the same task again. So we can pick A, B, 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 or A, B, B, or in any order, right? Now the last one is more interesting. We have series of A tasks and B, C, D, E, F, G, and n is equal to 2. So what we do want is, we want to wait for at least 2 slots before picking up the same task again. So rather than doing A, idle, then A, idle, then A, idle, we'll do A and finish up the rest of the task. So we finish A, then BC, then A, then DE, then A, then FG, right? And then still we have how many? 3 more A's left, right? So we pick up the A again, idle, since we cannot do any other task, we have to wait, then A, then idle, and then A again. Okay. Now before I go on and start the solution, please take a minute and think of an approach that you would take to solve this. Ready? Okay, let's start with this. Okay. So if you see, it is not basically a problem that we have to do and find all the possible permutation combinations and then find the least amount of time taking one, right? Rather, it's a mathematical calculation. So if there is a task that has the highest frequency, in this case that is A, we know that before picking up A again for n greater than 2 or greater than 0, before picking up A again, we have to wait for some time. So rather than waiting for some time, why not finish some other tasks? So since there is a gap of 2 between picking up the A again, we'll start with the highest frequency. We'll finish up the rest of the task that we can before picking up A again. And then similarly, we can find out. So we need to come up with the formula that we can use. If we see A has the highest frequency 6, But how many times do we need to wait between a's? We have only need to wait in this period, this 5 times multiplied by n is equal to 2. That is, a's frequency is 1 2 3 4 5 6. 6 minus 1, 5 into 2, 10, right? So 10 idle slots are there, but in these idle slots we want to reduce this overall number of idle slots. Why? Because for n equal to 0, if you see, the overall answer is going to be the task length. In any case, the solution is going to be the task length plus the idle slots. Now idle slots we can calculate based on the highest frequency, 6 minus 1 5. Why minus 1? Because we start with a, then we wait, then a, then wait again, that is second time, then third time, fourth time, fifth time. So 1 minus the highest frequency, highest frequency minus 1. So 5 and then multiplied by the time slot, that is 2, 10. Now we have to wait for 10 slots. Now what we are going to do is, we want to come up with how many slots we can use with the rest of the characters, right? And once we have that, we are going to reach our final set of slots. So let's say in the beginning we have total idle slots as 10, as we just calculated. So we'll reduce the idle slots from we'll iterate from the max frequency, and then we'll reduce the overall idle slots one by one. Okay, so it would be a little confusing this way. Let's start with the code and it will be much simpler to understand it. Okay, let's start. Okay, first we need an array to store the frequency. So array to store the frequency, int task frequency is equal to new int of 26 for each character, right? Then we'll count the frequency for each task, count the frequency for each task. For character task, from tasks task frequency, that is task minus capital A, since all the tasks are in capital format, and we use this because we are using the ASCII value for the characters to convert them to integers. Okay, as we have covered this in multiple solutions earlier in this series. Now we are going to sort the task frequencies in the ascending order. So sort the task frequency in the ascending order. We'll use arrays dot sort, will pass task frequency. Okay, now it is sorted. We'll get the max frequency. Now since they are sorted, the max frequency would be at the end of the array. So get the max frequency. So we can say int max frequency is equal to task frequency at the last index, which is 25th, right? Now let's calculate the idle slots. So calculate the idle slots based on max frequency. Okay, so int idle slots is equal to max frequency minus 1, as we discussed, multiplied by n. Now we are going to iterate over the task frequency in the descending order. So iterate over the task frequencies in descending order. Actually, we should not have a the in this case. Okay, so for int I is equal to, we'll start from 24 because 25th has already been covered. I is greater than equal to 0. Also task frequency has to be greater than 1, right? Because for if we consider this example, for after G, for H I J K L M, or let's consider this example, in this case A and B have the task frequency 3 3, but C D E F G, all of them have the task frequency 0. So once after the sorting, their array is going to look something like this: 0 0 0 0 0 dot 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 3 3, right? So we'll start from the 24th, that is this 3. Okay, so for all and all the task frequency 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 of I has to be greater than 0. So we don't cover for these, right, since these are not part of our tasks anyway. I minus minus. Okay, now idle, this way we are actually going to distribute the idle slots. So we'll write it: distribute the idle slots among other tasks with frequency freq frequency less than the max. Okay, so we can say idle slots minus equal to math.min max frequency minus 1, or the frequency at that point, task frequency of I. Why do we have this max frequency minus 1 or the task frequency? So we want to pick a min, right? So max frequency minus 1 comes from the point that we have 3 tasks. Let's say we have A, and A. We are going to need a slot only in the middle of these tasks. So it will always be the max frequency minus 1, right? That's where we get the max frequency minus 1 from. Next is, where do we get the task frequency of I from? For slots that have 0 values, we don't want to pick them up. We are anyway not picking them up. So for the slots that have only 1 frequency, we'll use only 1. Okay, we'll not go with the max frequency. This will be helpful if we have 3 and then 3 again, right? And also because of our first max frequency. Now in the end we can return, or I'll mention, the result is either the total number of tasks or total number of tasks plus idle slots that will be left in the end. So we can say return math.max of task.length or tasks.length plus idle slots. Actually we could just return task length plus idle slots. I don't see any change in that. Let's run it. Oops, there is a compilation issue. I was typing too fast, or I was trying to type too fast, let's say. Okay, still frequency, right? Frequency. Okay, let's submit, and the overall time complexity is going to be O of n. See, as I mentioned, I had submitted the solution earlier as well, and I had uploaded the video, but yeah, it was not well explained, so I had to redo it. Okay, let's take a quick dry run. Okay, so we have the given task A, B, B, B. So the max frequency is going to be 3. So max frequency is equal to 3. Okay, so total idle slots is going to be max frequency minus 1, that is 3 minus 1, 2 into 2, since n is equal to 2. So idle slots is equal to 4, right? Now if you see, we are going to reduce these idle slots because we are going to use 2 of the idle slots in the middle to take up other tasks, and we'll be left with 2 idle slots. So the overall solution is going to be task length, that is 6, plus the leftover idle slots, that will be 2. So 6 plus 2, 8, right? As of now idle slots is 4. So we start with 24th that is this 3, right? This is the 25th index. We already covered this one, so we take the 24th index. I is greater than equal to 0, true. Task frequency of I is greater than 0, yes. I minus minus. Idle slot is equal to math dot min, so idle slots minus max frequency. What is the max frequency? Max frequency is 3, and task frequency of I is 3. Max frequency minus 1, 2. So 4 minus 2, it will become 2. Right? Next we come up again and we see the next task frequency. Next set of task frequencies are 0, so we do not care about them. So the loop ends here, and we return math task length plus idle slots, that is 2. So task length 6 plus 2, 8. Let's take this example as well. Okay, in this case the max frequency is 6, so we'll keep the max frequency as 6. Idle slots is going to be 6 minus 1, 5 multiplied 5 multiplied by n, that is 2. 5 into 2, 10. So idle slots in the beginning is 10. Now we are going to use 6 of those idle slots. Okay, so if you see, we use one idle slot here, second idle slot, third idle slot, and then we have 1 2 3 4 idle slots left. We'll use up 6 of these idle slots. Okay, not all idle slots are coming from A, but we use them, right? So we start with I equal to 24. The array for this one is going to look something like this: 0 0 0 0 0, and then dot 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 dot. Then for we have B C D E F G, 1 2 3 4 5 6. So it's going 1 1 1 1 1 1 and then 6, right? That is the frequency of A. I equal to 24, so we pick this one. I is greater than equal to 0, true. Task frequency of I is greater than 0, yes. Idle slots is equal to math dot min, max idle slots minus max frequency minus 1, that is 6 minus 1, 5, or task frequency of I, that is 1. So 1 is smaller, so idle slots gets removed by 1. So one of the idle slot is used by one other task, so it becomes, from 10 it becomes 9, right? Because B used one of that idle slot between A's. Then again we pick up the next one, and again it gets reduced, it becomes 8, because C used one of the idle slots. Similarly, D used up 1, E used up 1, F used up 1, G used up 1. So 1 2 3 4 5 6, 6 slots get removed from 10 idle slots, and it becomes 4. In the end, the answer is going to be task length, that is 6 plus 6, 12, plus idle slots, that is 4, 16. So 16 is the answer. Okay, I hope it was clear to everyone. So that's all from today's video, guys. If you have anything, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.